Hey there. So if you are watching this, this means you missed the graphing and I'm making a video for you so you can get caught up. All right, so what we talked about when we did this is we first got familiar with the shapes of graphing. So we started with the first part of chapter 6, which was first semester, and graphing exponentials, which is this example that you see right here. And we made our table, and we started out with the easy amount of x being 0. And just remember, these are the x values we always picked. We did get rid of the 3. And anything to a 0 power is 1, and 3 to the first power is 3, and 3 to the second power is 9. And then you get these fractions over here. And the reason why you get these fractions is because when you take 3 to the negative is going to take whatever 3 to the second power is and move it, and that's why we get 1/9 and 1/3. So we had also talked about inverses, and that exponents and logs are inverses of each other. So since we're still not very good with logs, I can get the points for this by using the points from this table, because since they are inverses of each other, what will happen is the x's here will become the y's over here, and the y's that are over here will become the x's over here. And those are already filled in for you. And at this point, since we scribble out the 3, I'm going to get rid of this whole 27. So what we did first is we graphed our exponent tables, the table on the left, and we did not graph the 1/9 and 1/3 coordinates. We just graphed 0, 1, which is here, 1, 3, and 2, 9. And we went over that this is growth, and you know it's growth because the base that's attached to the exponent is bigger than 1, and growth in an exponent looks like this. So we have this shape that's kind of coasting, and then it starts to go up. And there is a wall, and I'm going to show the wall, and then I'm going to get rid of it right now. The asymptote for an exponential is here, but I don't want to keep that because I'm about to graph the other one. So anyway, I have this wall, which I'm now erasing. All right, so now I can graph a log. Again, I'm going to graph these points, and I got these points simply by switching these around. Since exponents and logs are inverses of each other, I can just switch their points, because that's the first step of an inverse, is x becomes y and y becomes x. So again, I'm not going to graph the ones with the 1/9 and the 1/3. I'm going to graph 1, 0, 3, 1, and 9, 2. And now what's different is before, when our wall went along the x-axis, it's going to be the exact opposite. So instead of our wall going left to right, our wall is going to go up and down, and it's actually just going to be the y-axis right here. Okay? So what's going to happen is this shape is going to kind of coast along this wall and go like this. So growth in an exponent looks like this shape here. Again, I'm just going to re-highlight it. But in a log, it looks like a lowercase r. So what I need for you to do is be very familiar with that shape, that since this little base is 3, you should be looking for a lowercase r when you're done. Okay? And the other thing we talked about in class is that this orange and green shape, these are actually just mirror images of each other. You can draw in that so-called mirror by drawing in the line y equals x, and then act like that red line is the mirror and the orange reflects the green. So that is growth in an exponent and growth in a log. So we skipped this part, and now I'm going to go to this one. So here what we talked about is decay. So I know it's decay because this is less than 1, but I still started out with 0. Anything to a 0 power is 1. 1/2 to the first power is a half. 1/2 to the second power just means a half times a half, which gives you a fourth. And we got rid of the 3 because, again, when we chose the points, we only did -2 through 2. And then these become 2 and 4. So again, the reason why is if you take a half to the -2 power, it's going to take a half times a half, like this, and then it's going to take that 1/4 and move it. So that's why it becomes 4. So now what I can do is find the points of its inverse. So again, I'm not very good with logs, and so that's why I'm going to the trouble to getting my points over here with this exponents. But inverses means that these y's are about to become these x's. So we'll do that real quick. And that these x's over here are about to become the y's over here. So inverses, things just switch. So I'll have -2, -1, 0, 1, and 2. So I'm going to start by graphing the exponent one. I will leave out the 1/2, 1/4 coordinates, but here's -2, 4. There's -1, 2, 0, 1. And when it's decay looks like this, kind of like a capital L. So I'm going to go ahead and do that. And there is that wall along the x-axis. It's just cruising along. But this is my shape. And now I'm going to graph my log points and show you what those look like. So whoops, 4, 2, 1. This was supposed to be a 1/4 here, but I'm going to leave those fractions out. So I'm going to graph 4, -2, 2, -1, and 1, 0. And again, there is this wall now. A log has the opposite wall. So instead of going left to right, it's going up and down like here. And the shape is going to coast along the wall and look like this. So these shapes are very similar in that they both go down. So decay in an exponent looks like this, but it will also look the same in a log. So the only one that you have to get newly familiar with is the R shape from the other side of your notes. Anyway, as it turns out, these are mirror images of each other. If you want, you can draw on that mirror, and it's just the line y = x from corner to corner. And if you turn your paper so that mirror is kind of more up and down, these should be reflecting each other, mirror images of each other. Okay, and again, we skipped this part and then we went into here. So the first thing we did was reacquaint ourselves on these letters, and that A is our stretch and compress, and sometimes flip if we see a negative. H we want to take the opposite of, and then that is our left-right number. And H is always in a house. So here our house is parentheses. And then K, you just leave it as it is, but that's your up and down number. So the first thing we talked about, we looked at 1, 2, and 6, is we did the, what are these extra numbers that have jobs? So looking at problem 1, 3, I want to see that as a -3, and that's going to go left 3. And 4, I want to keep that -4 as it is and realize that that means down 4. So the stuff I didn't look at was this, and this is the parent function. Every function has a parent function, and what I boxed in is the parent function. So when you go to number 2, this 2 has a job of a stretch. This 2 I want to look as the opposite, and that means I should think -2, which goes left 2, and this will move it down 1. And the things I didn't address was this part, and that's the parent function. So then we jumped real quick to number 6, and we talked about this one, that this 2 has a job of right 2, and this has a job of up 1, and that this is the parent function. So let's go ahead and get started. I'm going to go back to problem number 1. So if we kind of do what we did in the first part of the video, is I need to figure out the points of the parent function. So I need to figure out the points that work for this. Unfortunately, we're probably not as good with logs as I'd like for us to be. So what we're going to do is we're going to first look at this as an exponent. And what we did take a moment to discuss is that we need, in order to look at this as the exponent, what's highlighted in yellow, we need to find the inverse. So that's what we talked about first. So I kind of jumped to a different part, and what we're going to look at is we need to find the inverse of this, which was the section that we just talked about. And the first step of inverses is everything has an inverse. Adding has its inverse of subtracting, multiplying has its inverse of dividing, squaring something has its inverse of square rooting, and even letters have their inverse. So the inverse of y is x, and the inverse of x is y. So first we rewrote it, and to make it a function, we need this y to be alone, but y is very special here because it's part of the log. So this is where I had you guys circle it, and now we're ready to turn that log into an exponent, because the only way to get to the y is when it's not in the log, and the only way to undo the log is to make it an exponent. So we talked about that this base of 2 is the base of the exponent, and then we go to the other side of the equal sign to the x power, and then it comes back and equals y. So it looks like an e, it's just a backwards e. So that is the inverse of the parent function, of this parent function. So there is a shortcut, so you don't have to do this over and over again. So let me show you that shortcut. And if you look at what's highlighted, specifically, you look at this little part right here, you can kind of see 2 to the x. So since we're not good with logs, we're going to do this idea of what we did up here. We're going to find the points of 2 to the x and then switch them so that we have the parents of the log function. So let's do that. We're going to make a table, and we're going to speed this process up as we go through it, but let's start here. So I'm going to pick x and y, and remember we had to pick x. Here they are. These are the numbers we used. And I'm going to start with the easiest one. 2 to the 0 is 1, 2 to the first is second, 2 to the second is 4, and then these become 1/2 and 1/4. So now, because I have those points, I can find the points of the parent function of the log. And what will happen is these y's will become the x's over here. And then the y's that are over here, I'm sorry, the x's will just become the y on the other side. So -2, -1, 0, 1, and 2. So the points that I'm really interested in are these over here, okay? The other points were just helpful to help me get these points again. And we're doing the first table because we're not that great with logs. So after we got our parent function points, sometimes we would make another y column. And we would do that when we would have a stretch, compress, or flip. We don't have that here, so I don't need to make a new y column. So what I'm going to do is graph my points 1, 0, 2, 1, and 4, 2. So here's 1, 0, here's 2, 1, and here's 4, 2. And this is growth. And I know that because whether you look at this base of 2 or this little base of 2, this is growth. And you got to remember that growth in a log looks like a lowercase r. So these points are about to move. They're about to have their transformation, and they're all going to go left 3, down 4. So I'm going to take these 3 points and just go left 3, down 4, left 3, down 4, and the last one, left 3, down 4. I might be a little bit off there. So the other thing that has moved is this wall. Right now my wall is along this y-axis here. So that wall is about to move, and it is going to move left 3. If you move it down 4, it really hasn't changed its place. So it's going to be right here is the final wall. That actually has an equation of x equals -3 because every point on this line has an x value of -3. So now I'm going to connect my final points. It's going to cruise along the wall and then make that turn so it looks like the lowercase r. All right, we're going to go ahead and graph the other one, and then we're going to come back and talk about the domain range and stuff like that.